With everything in place, it'll be time to start a new chapter in our history. For the Artemis 3 mission to take humans to the moon's surface. After those first astronauts have proven this new route to the moon, what will we make of this opportunity? How might a moon base camp look years after we return to the lunar surface? There may be large structures for mining facilities, geological research, and transportation networks for materials and inhabitants. The materials and resources found on the moon will also be important for sustained exploration of the lunar surface. Astronauts will periodically venture out on the surface in spacesuits, their own personal spacecraft. On the moon, there are many dangers. The vacuum of space, drastic temperature changes, abrasive moon dust, and space radiation are just some of the challenges. So, for much of their stay, astronauts will be protected inside habitats underneath the lunar regolith. It's safer below the surface of the moon. From here, they will use telerobotics to control robots up on the lunar surface. It's also safer above, orbiting high overhead. From the gateway, astronauts will be able to remotely operate robots at multiple sites across the moon. In contrast to controlling them from Earth, there is almost no time delay, making delicate and responsive movements possible, with the ability to react to rapidly changing situations. Early Artemis missions will land in the southern polar region. This largely unexplored area offers exciting opportunities. Found within the South Pole Aitken Basin, the 21-kilometer wide and 4-kilometer deep Shackleton crater is a possible landing site for the Artemis program. This region on the lunar far side holds important clues for understanding the geology and history of the moon. Also, in the southern polar region, the sun's light reaches the surface nearly parallel to the ground, casting long shadows. With no atmosphere to scatter it, this sunlight can never reach within several of the region's deeper craters. At the crater rim, it's always day, but the depths lie in eternal darkness. With temperatures down to negative 248 degrees Celsius or negative 414 degrees Fahrenheit, these craters may well conceal water ice. Water is necessary for astronauts to drink, but it can also be split to provide hydrogen and oxygen. Oxygen to breathe, and oxygen and hydrogen are fuel for rockets.
The Viper mission, which stands for the Volatiles Investigating Polar Exploration Rover, is a mission that's following on the heels of a number of previous lunar missions all about the hunt for water ice on the moon. And so if you could actually get it right there on the moon instead of bringing it from Earth, be a game changer for saving on the cost to do it and just the convenience of having it right there where you're working on the moon.
Viper is a four-wheeled rover. Each of its four wheels can independently drive, steer, and have height adjust. If the entire rover is embedded in soft soil, the combination of it could bind into a walking, crawling, or swimming type behavior, enabling it to slowly extricate itself from this stuck condition.
Robotic technologies are crucial for realizing the vision of lunar exploration and off-world economy. Future robots will be more independent, using artificial intelligence to make decisions about how best to complete their assigned tasks. Dozens of innovative robots are under development for a wide range of roles.
Duaxle is essentially two axle rovers joined together to drive as one. And the benefit there is that you can go and explore much more terrain versus being tied to a lander. When you hit the surface, you can actually drive around a crater, or you can go many, many kilometers to visit some new site. Most recently, a mission called Moondiver. So Moondiver is an interesting mission to go explore a lunar pit, but the idea is to send a tethered rover into that pit and explore the sides. And the sides are more akin to unlocking history, almost like you're reading a textbook. And so answering those questions of how did we get here, where are we going, and did life ever get started in our solar system are paramount goals for NASA.
Robots will be central to one of the most exciting opportunities the moon offers. Deploying a radio telescope, able to look back at the very beginnings of our universe. Out there, we know, are faint radio signals sent from the far edge of our universe, called the cosmic microwave background. In addition, hydrogen signals emitted from the dark ages of the universe, before the first stars formed, are received at low radio frequencies. Sadly, these dark age radio signals are swamped by the constant radio chatter coming from our own planet and the ionosphere above the Earth's surface. Earth's radio signals spread out through space, but they are blocked by the moon's rocky body, creating a radio shadow in our own backyard. The moon always keeps the same face turned away from Earth. This creates the only place in the solar system that is consistently shielded from our planet's radio pollution. Here in the silence, what secrets might we hear, whispered from the universe? A large surface telescope called Farside will only be possible when the gateway enables direct human contact with the far side of the moon. Only then can astronauts telerobotically deploy and maintain such a facility. The moon is only the beginning of our exploration. Missions to the gateway and the moon's surface will provide a testbed for developing new and better systems for living and working in deep space. Leaving the lunar gateway at its farthest point from the moon requires a lot less fuel than launching from the surface of Earth. This makes it easier to return home or to set off toward other worlds. No human has ever visited another planet, and for very good reasons. Firstly, the distances are huge. Each round trip to Mars will take over 2 years, longer than any previous crewed mission. SLS will help deliver supplies and equipment into Martian orbit and its surface in preparation for a Martian landing. It's a challenge worth pursuing, not just for human achievement, but also for scientific discovery. The first humans NASA sends to Mars will use spacecraft and technologies developed directly from the Artemis missions. With Artemis, we are advancing technology. We are expanding our scientific knowledge. We are launching the next era era of space exploration. We're taking the next steps into